This is ammonia, NH3. In NH3, one hydrogen is going to be replaced by an OH group. So you get NH2OH. This is called as hydroxylamine. Hydrazine is NH2NH2. So again, from ammonia, one hydrogen is replaced by an NH2 group. So you get NH2NH2. This is called as hydrazine. Aldehydes give bright silver mirror. On warming with freshly prepared ammoniacal silver nitrate solution, which is called as Toland's reagent. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 4 of the chapter Aldehydes, Ketones and Carboxylic acid. So in the last session we studied the preparation of ketones, as well as we started with the chemical properties of aldehydes and ketones, right? So the continuation of that we are going to do in this session, that is the condensation reaction with derivatives of ammonia, Clemmensen reduction, Wolff-Kishner reduction, and the different tests to distinguish aldehydes and ketones. Okay, all of this we are going to discuss in this session. So let us continue with the next set of chemical reactions of aldehydes and ketones. So the first one we are going to discuss today is condensation reaction with derivatives of ammonia. That is ammonia and the derivatives of ammonia. So ammonia is NH3. Derivatives of ammonia means one hydrogen will be replaced by another group. So you can generally represent it as NH2Z. So this Z will be the other substituent. Reacts with carbonyl group of aldehydes and ketones to form condensation products. The reaction is reversible and catalyzed by acid. The equilibrium favors the product formation due to the dehydration of the tetrahedral addition product. The net result is replacement of the CO group with the CNZ group. Okay, so what is this? In each reaction when we are going to discuss, it will be clear for you. So what we are going to see is the reaction of aldehydes and ketones with the derivatives of ammonia. Okay, so the first one is reaction with hydroxylamine. So what is hydroxylamine is? This is ammonia, NH3. In NH3, one hydrogen is going to be replaced by an OH group. So you get NH2OH. This is called as hydroxylamine. So OH stands for hydroxyl and it is obtained from ammonia. So it is hydroxylamine. Clear? So aldehydes and ketones reacts with hydroxylamine in weakly acidic medium to form oximes. So what we are going to get here? Oximes. So let's see. So it is shown here RCO, R dash and H. That means if it is an aldehyde we are considering, it is going to be RCOH. If it is a ketone, it is going to be RCO R dash. So it can be either R dash or H. If it is ketone, both are going to be alkyl or aryl groups, right? So this is going to react with NH2OH. We have written it in the opposite way so that the hydrogen and oxygen will come together so that it will be easy for us to understand the removal of water. So the hydroxylamine NH2OH is going to react in presence of acidic medium. What is going to happen? Water is going to be removed. H2 from the hydroxylamine and oxygen from the carbonyl group is going to be removed. So what is happening? The other things is going to combine. R dash or H will be there. Double bond NOH you are going to get. Double bond NOH you are going to get. The water will be just removed from there. So this is the oxime which is formed. Clear? Okay. So for example, if you are taking an aldehyde, what is going to happen? You have RCH will be there. Okay. Reacts with H2NOH. That is your hydroxylamine. In presence of an acid, what is going to happen? H2O will be removed. What you are going to get? RCH will be there. Double bond NOH and water will be removed. So if it is a ketone, instead of hydrogen, there will be an alkyl group. Clear? So formaldehyde reacts with hydroxylamine to give formaldehyde. Okay. So that is HCHO. Is formaldehyde, the first aldehyde. It reacts with H2NOH, that is NH2OH hydroxylamine. Water will be removed. So you will have HCH double bond NOH will be formed. That's it, simple. And water will be formed. So this is formaldehyde. Clear? Now, moving on to the next one, reaction with the hydrazine. Now, what is hydrazine? Hydrazine is NH2NH2. So again, from ammonia, one hydrogen is replaced by an NH2 group. So you get NH2NH2. This is called as hydrazine. Now we are going to replace hydrazine here. So aldehydes and ketones reacts with hydrazine to form hydrazone. So it is called as hydrazone, the products which is formed. So again, we are taking an aldehyde or ketone based on whether it is an alkyl group or hydrogen. So what is going to happen in NH2? One you will write like this and another one you can write like this. So what happens? This hydrogen and oxygen will be removed. So NH2 is written here. So again what you are going to get, the water will be removed, these two will be combined, you will get RCR dash or H, double bond NNH2. Double bond NNH2 will be formed, which is the hydrazone. So one example which is shown here, formaldehyde is going to react with hydrazine to form the corresponding hydrazone. So you have HC double bond OH reacts with NH2. Again water is removed, H2O is removed. So you will get HCH double bond NNH2. Okay, so this is the hydrazone which is formed and water is removed. Clear? Now moving on to the next one is reaction with phenylhydrazine. Now what is phenylhydrazine? You have NH2 which is called as hydrazine, and NH2 NHC6H5 is called as phenylhydrazine. That means NH2 is hydrazine. So in this, one of the hydrogen is being replaced by a phenyl group. So what you will have, NH2 and NHC6H5. One hydrogen from here is replaced by a phenyl group. So that is called as phenylhydrazine. So again, what you are going to get? You will get a phenylhydrazone. Okay, so let's see. The aldehyde and ketone again reacts with NH2, NHC6H5. So again, water is going to be removed. You will get RC, R dash or hydrogen, double bond NNHC6H5. Water will be removed. Okay, so this is the phenylhydrazone you are going to get as water will be removed. Now let's see here, formaldehyde, it is going to react with phenylhydrazine. Again water will be removed, so you will get C double bond NNHC6H5. Clear? So this is in case of an aldehyde. So if you are having a ketone, what it will be? Let's take acetone, CH3 double bond O you are having, which is your ketone, and to which we are adding the phenylhydrazine, that is NHC6H5. So in all these reactions we are seeing water is only which is getting removed and the other products will just get combined together. So you can remember easily, these reactions are simple. So what is going to happen? This H2 and O will be removed, others will combine. So you will have CH3 double bond NHC6H5. So in presence of acidic medium, what is going to happen? You will have the CH3, then you will have the double bond, and what is left here? NHC6H5, which is the phenylhydrazone, and water will be removed. Clear? Next one is reaction with 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine, it is also called as 2,4-DNP. So you have seen 2,4-DNP in the lab also while we were testing for the functional groups, right? So 2,4-DNP, the full form is 2,4-dinitrophenylhydrazine, which is used as a test for the identification of aldehydes and ketones, right? So what is going to happen here? Aldehydes and ketones reacts with 2,4-DNP to form 2,4-dinitrophenylhydrozones. Hydrazine will become hydrazone. So what is 2,4-dinitrophenylhydrazine? Again NH2, okay? NH2 is your hydrazine. To this hydrazine, one hydrogen is going to be replaced by a dinitrophenyl group. Okay. So what is going to happen? Aldehyde or ketone we have taken NH2, NH, and this is the phenyl 2,4-dinitrophenyl part. That is on the first and fourth carbon atom, you are having two nitro groups. So what is going to happen? Again the same thing, H2O will be removed and these two are going to combine. So you will have RCR dash double bond NNH and this much group will be there. Simple, right? You will get 2,4-dinitrophenylhydrazone. So let's take again with formaldehyde. What is going to happen? HCHO we have taken, NH2, NH and the 2,4-dinitrophenyl part. What is going to happen? Water is going to be removed again in presence of acid. What is going to happen? We are going to get the corresponding phenylhydrazone. Clear? Right. The next one is Clemmensen reduction. So we have completed the condensation reactions where we are removing water. So in all the ammonia derivatives, what is the step we have to do? We have to just remove the water molecule from there. Clear? Now the next one is Clemmensen reduction. So the reduction of aldehydes and ketones into corresponding hydrocarbon. So what you are getting here? Hydrocarbon. So if you want to form hydrocarbons from aldehydes and ketones, which is the reaction that you have to use? It is Clemmensen reduction. Reduction means what? We are going to add hydrogen here. Okay. On treatment with zinc amalgam and concentrated hydrochloric acid. So what is the reagent used in Clemmensen reduction is also very important. That is zinc amalgam and concentrated HCl. So what is going to happen here? During the reaction, carbonyl group of aldehyde or ketone is reduced to CH2 group. That means it is simple. Wherever you are having the CO, that is carbonyl group, it will be converted into CH2. So this is what you have to remember in case of Clemmensen reduction. So you have the ketone which is taken here, RCOR dash. So 4 moles of hydrogen is going to be added here. What is going to happen? As simple as that, you can remember, in presence of zinc amalgam and concentrated HCl, this CO is going to be converted into CH2. So what you will have? RCH2R dash. So all of these are alkyl groups, right? This is also alkyl group. You have CH2, another alkyl group. So you'll get RCH2R dash. What it is? It is going to be a hydrocarbon, right? Any other functional group is there? No, right? This is an hydrocarbon. So let's take an example of formaldehyde itself. CHCHO, right? This is formaldehyde. It undergoes hydrogenation. That means it is undergoing Clemmensen reduction in presence of zinc amalgam and HCl. What is going to happen? Again, CO is going to get converted into CH2. So you already have 2H and you have CH2. So combined together, what you will have? CH4, which is methane is obtained by the removal of water. So the next method we are going to see is Wolff-Kishner reduction. So the reduction of aldehydes and ketones to corresponding hydrocarbons by heating with a mixture of hydrazine. What was hydrazine? NH2NH2 and strong base like KOH in ethylene glycol is called Wolff-Kishner reduction. Okay, so hydrazine and in presence of potassium hydroxide and ethylene glycol. That is a reagent here. In Clemmensen reduction, the reagent was zinc amalgam and HCl. So what is going to happen? During the reaction, CO group is converted into CH2. In this reaction, carbonyl carbon is first treated with excess of hydrazine to get the corresponding hydrazone, which upon heating will give you the hydrocarbon. So in both of these reactions, that is Clemmensen reduction and the Wolff-Kishner reduction, what you are going to obtain is same, that is hydrocarbon. The CO, that is a carbonyl group, will be replaced by CH2. CO is going to get converted into CH2. But the reagent we are using here is different. In Clemmensen reduction is zinc amalgam and HCl. In Wolff-Kishner reduction, it is a mixture of hydrazine as well as potassium hydroxide and ethylene glycol. So we have taken a ketone here, RCOR dash, it's a ketone. Okay, to which we are adding hydrazine first, that is NH2NH2. So the condensation we have already studied here, hydrazine gets converted into hydrazone, right? So water will be removed, you will have RC double bond and NH2. So this is what you are going to get, which is hydrazone, intermediate product, to which we are going to add potassium hydroxide in presence of ethylene glycol and heat it. What is going to happen here is, as discussed already, in short, if we are going to tell, the CO will be converted into CH2. That's it. So now what is going to happen here? Here you will get a CH2 and this will be removed. This bond will break. So what you will have? RCH2R dash and nitrogen gas will be evolved. So let's take the example of formaldehyde here. HCHO, to which hydrazine is reacting, which is the first step. What you will get? The corresponding hydrazone by the removal of water, to which we are adding potassium hydroxide in presence of ethylene glycol. You will get CH2 here by the breakage of this bond. Again, CH2 and 2H is there. So you are going to get methane and nitrogen gas will be evolved. So without writing all the steps also you can write. For example, let's take CH3, COCH3. What it is? It is acetone. It reacts with hydrazine in presence of potassium hydroxide and ethylene glycol. All of this are happening in the same step. What is going to happen? The CO will be just converted into CH2. That is CH3, CH2, CH3 you are going to get. That is propane you will be obtaining. Clear? So this is simple. So I hope it is clear. In Wolff-Kishner and Clemmensen reduction, CO will be converted into CH2. Right? Like that simply you can remember. But what is happening? The reagent is different here. And in Wolff-Kishner, first hydrazone will be formed, then further by the addition of KOH and ethylene glycol, you will be getting the hydrocarbon. Now the next one is test to distinguish aldehydes and ketones. So this we have done in our lab as well, which is a test used to distinguish aldehydes and ketones, right? If many functional groups are given, for example, carboxylic acid, aldehydes, ketones, alcohols, phenols, amines. So in that, aldehydes and ketones, both of them together we can separately identify using various tests. So one test is Tollens test, in which you are using Tollens reagent, right? Aldehydes give bright silver mirror on warming with freshly prepared ammoniacal silver nitrate solution, which is called as Toland's reagent. So what is Toland's reagent? Ammoniacal silver nitrate solution. Okay. So the reaction occurs in alkaline medium and ketones do not respond to this reaction. So what is happening? Aldehydes and ketones can be distinguished using Toland's test. Toland's test will be only shown by aldehydes and not ketones. So this is your aldehyde, reacts with 2AgNH3 twice plus, which is your Toland's reagent, which is called as ammoniacal silver nitrate solution. Okay, in alkaline medium, what is going to happen? RCOO minus, that is carboxylate ion, silver will be deposited, water and ammonia will be formed. So this test tube, when you are checking, you will have a silver mirror will be formed. Okay, a silver mirror formation will be formed, which is actually by the deposition of silver there from the Toland's reagent. Okay, so this will be only shown by aldehydes. Ketones will not form the silver mirror. The next test you can use is Fehling test. Okay, that is Fehling's A and Fehling's B will be taken in equal proportions and added to the compound. So if it is forming a red precipitate, we can see aldehyde is present. Okay, so this method is also used for the, or this test is also used for the separation of aldehydes and ketones, identifying aldehydes and ketones. Ketones again will not show this test, only aldehydes will show. So Fehling solution is an alkaline solution of copper sulfate containing sodium potassium tartarate. So Fehling's A and Fehling's B will be there. Fehling's A is copper sulfate solution. Fehling's B is sodium potassium tartarate. So both of this we are going to take in 50-50 amounts, equal amounts as a complexing agent. Aldehydes on warming with Fehling solution gives a red precipitate of cuprous oxide. Cu2 foam O will be formed, which gives the solution a red color. So a red precipitate will be formed. Okay, and aromatic aldehydes do not answer to this test. So one more point you can identify from here, that it is going to be an aliphatic aldehyde. Clear? So the aldehyde reacts with Cu2 plus stands for the Fehling's A and OH minus the Fehling's B. What is that you are going to get? Cu2O will be precipitated. Cuprous oxide will be precipitated. That's a red color or red precipitate that you are going to see. Clear? So these are the two important tests which will help you to differentiate between aldehydes and ketones. Both of these tests will not be shown by ketones, it will be only shown by aldehydes. So it is very, very important which is the test used to distinguish between aldehydes and ketones. So you also have to remember which is the reagent. What is Toland's reagent? It is ammoniacal silver nitrate solution. What is Fehling's solution? It is made of Fehling's A and Fehling's B. What is Fehling's A? What is Fehling's B? All of this you have to remember. Okay. So in Toland's test, a silver mirror will be formed. In Fehling's test, you will get a red colored precipitate. So by this we can identify whether it is an aldehyde or ketone. So in the next session, we are going to study the oxidation of methyl ketones. That is, further reactions of ketones we are going to see in the next session. So I hope the concepts that I've covered in this session is clear for you. So that's all for today. Thank you.